Good evening, everyone. Thanks for joining. So, so today's session is titled "The Invisible Engine." So, over the next few minutes, we are going to explore the critical infrastructure layers that powers nearly the 90% of the modern cloud. Whether your ultimate career goal is to become a cloud architect, a DevOps engineer, or a SRE, or a system administrator, this session is designed for you. So, we are going to bypass dry academic definitions and talk about how production infrastructure actually operates in the real world. So, before we talk about terminal scripts or cloud environments, let's look at the sheer scale of the system we are discussing. So, how many times do you think you have interacted with Linux today? The reality is almost every single one of us did multiple times. Like if you use an Android phone today, its core operating kernel is Linux. When you stream a movie on Netflix, their content delivery network serves those video blogs using a highly tuned Linux servers. Also, the top 500 fastest supercomputers on Earth, 100% of them run on Linux. And also, the onboard software navigation system used by the NASA's Mars rover are built on Linux. So, when beginners think about working in cloud or DevOps, they often imagine a big style setup like a massive glowing 3D spaceship control room with tracking virtual threads. But if you walk into any major tech companies like Amazon, Netflix, or Google, the actual everyday reality is much simpler. It's an engineer staring at a clean, dark window with a blinking cursor. Yeah, it doesn't look flashy, but that simple text terminal is where the absolute power sits. Once you understand the right words to type into that terminal, you control the entire digital infrastructure. So, the flashy tool trap. So, now let's address a major pitfall that catches hundreds of aspiring engineers every day. So when you read a job description in cloud domain, you see incredibly exciting, catchy words like AWS, Azure, Docker, Kubernetes, so many words. It's very tempting to learn these tools on day one. But if you look at our architectural stack diagram, all of those advanced tools are just applications sitting on top of an underlying operating system. When a cloud instance crash or when a container stops responding, it won't save you with a graphical button. The web interface will may freeze. It may show a generic error, but the only option to save the day is to open a terminal shell, log directly into a server, skip. So if we skip these fundamentals of operating systems to learn DevOps, it's exactly like trying to build a 50-story building without a foundation. So today we focus on building that solid foundation. So if you talk about the architectural blueprint, this is the core concept of or the basics part of the Linux. So to master this, you don't have to be a coding genius. You just have to understand this core architecture. So it primarily boils down to three layers. So first, the core is the kernel. Think of the kernel like an engine or engine of car or central brain of a machine. It manages the memory blocks, schedules the CPU, and talks directly to the physical hardware. It acts as a middleman to the hardware and the software. And second thing right above the kernel is the shell, which is which this is the what you see when you open a terminal window. The shell is your interpreter. It waits for you to type a command, translates it into instructions, and executes and displays the output. And then we have the file system. It's an important part where in Linux operating systems, everything is a file. And in other open system, all the configurations are hidden behind a massive complex settings. But in Linux, everything running processes, network connections, hardware devices, everything are represented as a plain text, readable text files. So once you understand this philosophy, managing 1,000 cloud servers become logical and highly structured because configuring a server simply means editing a text file. So if you go into the practical insights, the power of automation. So in Linux, we can automate literally everything. So do you ever wonder why automation engineers refuse to use graphic interface? Like they only use the terminal command line interface every time because the mouse click does not scale. For example, like if we have to open a menu, like we have to while if we have a mouse, we have to click the menu item, open a terminal, like open a text file, edit the text file. It's so much time consuming. For example, if you have a task like create a 20 structure project directories, parse a massive log file for to find a specific error and route those error into a fresh file. This workflow with the graphical user interface means you have to right click, create a folder 20 times, open the text editor, search for the error, find the error, copy the error to a new file. It's very time consuming. But if you look at the command line approach, you can do all of that with the two simple, elegant lines of code. For example, I'll open up a I'll open up a folder here. Yeah. So this folder, if you want to create 20 folders here, what you have to do? You have to right click, create new folder, name the folder. It's too much time consuming. But in Linux, you can have it created using a simple one line command. So this is going to create a 20 structured folder with suffix as project and prefix with 20 numbers. You can see with single line of command, it created 20 folders. Also, you can see the error log file here. So if you open that error log file, we have different errors here. So if you want to get a specific errors to another file, we have another command. So this will create a new log file with only those specific error statements. So this is the power of command line. So these are the basics of the command line where we need to study before getting into a cloud or DevOps career. Also, you won't have any graphical user interface like this in Linux. You'll only have this command line interface. So the basic commands, you have to adapt the basic commands. And you can see we have 20 folders here. If you are going to delete, so we have a simple command to delete all those. It's going to, with a single line, it's going to delete all the folders. That's the power of command line. So how do you master this without getting overwhelmed? Like you don't have to memorize all these hundreds of commands or arbitrary commands. Nobody does that. What you actually need is a structured step-by-step roadmap. The first part is navigation, understanding directory, paths, layout on commands. So the basic one is the navigation. You have to navigate through directories, navigate opening files, creating files, deleting files. Those are the basics of command line. Then it's the security and permission. So security in cloud, security is everything. Without security, you cannot go. So enforcing user scopes, like you must learn who has permission to read, write or execute a file, how to manage access controls, etc. And next one is a configuration. So it's like the settings in other OS, in Windows or something, but in Linux it will be entirely different. So it's like how to checking running ports, installing software. So if you look into Windows, you will have a graphical user interface to install a software. But coming to Linux, it's very different. You won't have a graphical user interface. You just have a text box, which is a terminal. And you have to execute command, execute. So there's a different methodology, like executing one application. You cannot execute it directly. We have to have executable permission to execute an application. So those are basic fundamentals. And last one is automation, chaining tasks programmatically using bash script. So what I showed you earlier, it's we can automate that using bash script. So if you are creating folders or creating files regularly, you can create an automated script using bash. So as you go down this path, it's one more rule in Linux. So Linux assumes you are a professional. Like in other operating system, if you try to delete a core file or any other system files, it will pop up a warning box saying, "Are you sure?" But Linux doesn't do that. So if you try to delete the entire root directory, Linux will do this without asking anything, quietly delete itself. So that's why we don't just teach you the commands, we teach you the safety guardrail so you can wield this incredible power safely. Yeah. So next, we introduce our foundation program to help you build the foundation systematically instead of trying to piece together random outdated internet tutorials. We are introducing a first core module under the cloud learning pathway, the Linux Essential for Cloud and DevOps. So this is a structured 1 month program designed to take you from the absolute basics to a complete terminal confidence. So it features a 15 hours of live interactive classes, but this theory alone won't make you job ready. So Linux, you cannot learn alone from theory. You have to practice it hands-on. So we have a dedicated 5 hours hands-on capstone project. Will configure and document a real-world server infrastructure scenario where you can showcase, like you can simulate a server, how how you work in a production server, how to handle errors and all. So yeah, so we'll be starting the batches on 20th July. So we'll be having all the command syntax, layouts, and security. All the capstone project and simulated live server projects, and we'll be having live training syllabuses details also.